Nerding and hoarding. Quick and dirty DIY electronics. Nerding and...
There you go. Welcome back to the Nerding and Hoarding show. Alright, so today, well, yes, I am going to show you how to make an operational amplifier, or not to build it, but actually just use it, and that is because we are going to build up to learning a little bit things so we can make an automatic gain control. But first, oh, is that nasty for you? I'm so sorry. Is it blinking terribly? Yes. So, yes. So if we take an incoming signal and we take an operational amplifier and we take the input into the input with the plus, which is the non-inverting, and we take the other one with the minus sign and the inverting input, and we put one resistor to ground right here and another resistor to ground right here. Then oh, I'm so sorry about that. Maybe it wasn't too terrible for you. Anyway, so depending on the relationship between these right here, the amplification of the signal will be different. I think it's sort of, not exactly, but a rule of thumb that if you have sort of 1K here and 2K here, your signal will become 2K divided with 1K and circa, this is the circa sign 2. Maybe not exactly like this, but sort of. And also if you take 10 right here, 10K, then you get like sort of 10 times amplified. So, and guess what? If you take this and instead you do like this, and you put a potentiometer here, yay! Then you can adjust the gain, but it will be sort of like maybe like this. If I make a little graph here, and this is 1 and this is 100, so it will be sort of like this, if you know what I mean. So it's not very useful to do it exactly like this right here. What could be more useful is to put one fixed, or maybe I should just erase. It's quicker, alright? Yes. So what can be more effective is to put one So you have two right here, am I right, people? Two resistors. Choose one of them to be a variable resistor, a potentiometer, and one of them to be a fixed one. So if we say that we put this one as 100k and this one right here as a variable resistor as having 10, or let's say 50k, then our output, and remember again, I'm not 100% certain about this calculation right here, but at least sort of, so we will be getting a value that goes from a gain of 2 up to a gain of, and now again, of course, it's impossible to divide with 0, but we want to put a 0 here, but instead I will put a number 1, and then the gain will be 10,000. So that could be helpful if you are sort of, maybe you are building a, if you are building an amplifier, but you also want it to work as, if you have an incoming sine wave, for example, and you want it to also be possible, so you want one output to be sort of maximum large sine wave like this, but you also want to be able to output square wave. Then the setting is quite good, because if you set this to, if this is 0 and this is 100k, then it will actually output maximum or minimum, like that. So then let's start to build this thing right here.
Quick and dirty DIY electronics.
So I have here a, so in my collection of 10 or less, which is a collection of modules that use 10 components or less, I have this number 006, and it is the non-inverting amplifier, and this uses the let's see, yes, the one that I erased, that design, you can see but yeah, like this. In, out, plus, minus, and but what we, or what I wanted to do was the other design that was more like this, with one fixed resistor, and then a variable resistor going to ground. So we're gonna remember this and make a little adjustment to this, but not terribly large. And also I had made a little addition to it. It was like this, just because that might help you to not burn this out if you connect it the wrong way. So if we do a little zoom in right here, I'm getting cold. I haven't remembered to put on any pants today because it's the International No Pants Day today. No, I'm just kidding, you know, I'm such a fun guy. And you know, this maybe, and you see, we don't need all this size right here because we could move these holes over here, and we could move this sort of over here, and we could move this one step over here. So yeah, at least we need 5. Yeah, now I'm talking about strip board because I prefer using strip board when making circuits with chips. And yes, so here it is. This is unfortunately printed in sort of 95% size, so we can't exactly see. You see, it's not really lining up here, so we have to sort of count. Alright, so I will cut this and pause you for a while because my videos are getting so long. Alright, there you go. Unfortunately, my camera stand has begun to wobble. You see? Hope you don't catch a seasickness from this. And I will try to fix this. And yeah, I pause again. So I hope that's a little better. So now, yes, when they drill with the drill machine is out, let's drill out some holes. Okay. Yes, but unfortunately this poor little nerd has lost his mind. No, he's not lost his mind. He's lost his tools, but you know. So, 1, 2, 3, 1, 2, 3, 4. Yes. One, 2, 3, 4, but we don't need 1, 2, 3, 4. 2 is enough. So let's take 3. 1, 2, 3. 3. Just making a quick pin out drawing here. Well, it's pretty straightforward. Just put this in here. As always, I ask you to send me a better idea on how to do this because I always put this in the wrong way. And you know, and I solder on the wrong side. And that's a bit annoying. This I have to have on this side, so you know. No. Alright, let's pause for a while again. So, and this chip right here, it is called LM358, and it is great. And this right here is called a pin header. And this is not great because it doesn't rhyme. So now let's see if we have any heat on the iron, so to speak. Because you know. Alright. So I said earlier that we are going to try to make an automatic gain control. And why is that, you might ask? And ask no more, because I will tell you. Well, it's like this. When I am working on some modules that have, let's say they have a low-pass filter, and a low-pass filter not only does it let low frequencies pass and high frequencies not pass, but it also shapes waves from square to triangle, but it also changes the output gain or the output amplitude. So in order to fix that so that every output is the same amplitude, I want to have an automatic gain control. Oh, now I made 2 solder bridges already. So there you go, I'm the master of solder bridges. But also, I mean seriously, this is not the way you're supposed to do it. You are supposed to solder on the side but have the components on the other side. So why do I keep doing it this way? Well, because all my layouts are drawn this way, and I am not having a good method to do it otherwise. And as you see, this soldering iron is not the best. Alright. 4 down, 4 to go, like they say. And I will try to make this crappy soldering iron a little less crappy. And how do I do that? Well, I don't know. Just wipe it off, I guess. Wipe it off with a little copper wire, entangled copper wire. Right, and we need some kind of panel, you know. Panel is the front side of the EURORACK or Cosmos rack or whatever rack you prefer using. I even have ideas about making a new size, which is 10 centimeters high instead of EURORACK, which is 12.8 or 12.85, because you can order PCBs which are 100 high for a very cheap cost. So then you can have the PCB as the front plate all together for really cheap price. Yes. So now pause for a while and I get the other stuff ready. So I just drilled this. I accidentally paused the video, but you see I can drill again just for your enjoyment. Output, input, gain control. All right, and then yes, it's a good method to always write on the front and the back what it is that you are putting in, because I often mix up, because it's when you turn it over it becomes mirrored and things change sides. So if you try to work quickly and you might be tired, you might mess it up and put the input to the output, and then you spend a long time wondering why nothing is working and so on. But just take a pencil and write on it. So you might see that I slightly changed the values here. We had 50 and 100 before, but unfortunately I didn't have any 50 pots because I'm running out of my pots, so I have to hoard some more. Yes, and I'm not having so much money. Yes, when I tried to pay my rent, my bank said, you don't have so much money. So that's a little bit of a problem. But you know, you have to think positively. Positivism is the best ism, isn't it? Well, it's actually some kind of ism that I don't really know about, so I shouldn't talk about that. Because popular and sort of academic definitions of things are not the same, such as materialism. Materialism in popular understanding is sort of the love of material things, but in academia it's sort of more like a belief that there is nothing more than the material world and the material things. I have no more information about this subject, except that something about Marxism being materialism. So, right, beautiful. Yes, and as I said, of course, pencil. Who stole my pencil? Sorry, I'm the only one here. In, out. If you have one of those pens that are acrylic, sort of white, that looks good to write on black, but I don't got it. Or I have one, but I lost it, and it's not white, it's black. So, you know, if you have one of those, please send it to me, and I will give you whatever you want, or I mean whatever video you want. Just tell me, like, make a video about, I mean, in the making modules with 10 components thing. So add a little pot, and because everything is white today, we add this one right here, and also I will write the code here, and this is called 006 non-in so I'm just making a little bit short about like that, because you know I have so many modules and I can't remember which is which. So now we have to zoom out, and we also have to adjust this right here to this right here, and so on. So okay, so this will be the minimum, which means that it will have to be the maximum resistance. So then this goes to ground, these two go to ground. I will actually use a very strange green color today, which is not green at all, but because I don't have any more single core cable of green color, and I'm so tired of using multi-core because it's so so hard to work with. Multi-core means that there are several copper wires inside of a wire. And this one only has one that is sort of thick. There you go. And if you know me, you know that I am a really nice guy. But I don't know you. Please write in the comments field below. Why are you looking at this video? And why did you start to be interested in electronics? Or did you just simply stumble upon this video by accident, as it's called in Britain? Welcome to my accident. I have an accent which says accident. Alright, I'm just sort of doing now. Doing. And I'm thinking about something called time challenge. Would you want to watch me build something really quickly? Would that be interesting? Sort of invite sort of famous people to build stuff as fast as they can. You know what's the guy that's called in the first name, him with the Moog synthesizer? Moog, Mr. Moog against Mr. Nerding and HOARDING. Soldering challenge, speed challenge. Build your best voltage control filter in 20 minutes. Well, Mr. Moog, you will be so fucked because your voltage control filter design is so hard to build. And mine is so simple. My. Alright, so this is, I have to put the, you know, if someone tells you there's a better method than using your mouth to peel the cable, they are wrong, because it's the best way to do it. Because the teeth is under your total control, while a plier is just sort of something that you don't use every day. Imagine how many bites you take every day when you eat, and how your control over the strength and power of your teeth is so total. Anyway, don't put the cables in your mouth, because they contain, or they might contain, poisonous plastic things, or even lead if you are using old cables. And you don't want to poison yourself now, do you? Alright, where are we now? I'm gonna start scratching over stuff right here. Yes, so I might need to, so my smartness is quickly decreasing when I try to do something quickly. Have you ever experienced this? Okay, so the problem now is that I will have to change the layout here because I want to add this one. And I'm not exactly sure on how to do it, but where did I put the drawing? Yes, it's right here, the drawing. And this one is this one right here. So then it becomes much easier for me. Thanks for that. Little help right there. I mean, I helped myself. And now I broke off the ground cable. Okay. Okay, so what do we need? What do we need? Two cables. Two cables. One for the outgoing signal and one for the incoming signal. So I'm choosing purple for the incoming for the outgoing signal. Why is that, you might ask? And I say, well, I just chose it very randomly. It has nothing to do with anything importance. So, Anya, I know you love to see my handiwork right here, so I will, of course, let you watch my craft skills. Or maybe you want to laugh behind my back when I screw it up, as I always do. Maybe I should change the name of the channel to The Solder Bridge. What do you think about that? The Solder Bridge. Quick and dirty solder bridges. Right. And as I said the word, guess what I did? Well, solder bridge. Yes, but because I make so many, I'm so quick at removing them. Yes. So that was down, as I say. I say, write that down. And then I mean, okay, I fixed that particular little problem. So, yes. So, Wangambardi Bodum. Oh, all right. Yes. I am not. It's not going so good for me. I'm so sorry. But you know why this broke off? Well, because I cut it with a plier, and pliers are a little bit more aggressive towards the copper because it's made out of steel, and steel is much harder than copper. So you have to be real careful when cutting something. I mean peeling the plastic off. Alright, so this is the output, and I have written out here so you can clearly see I'm doing the right thing here. I mean, do the right thing, don't do drugs, it's bad for you. Oh no, I messed up. Yes you did. I was planning on putting the chips right here, but you see now it's too short. I have to put it on here, but that's just perfectly alright, you know? It's just perfectly alright. Don't need to stress about it. So now take another cable and connect the input. I mean, if you're not on a 10 or less challenge, you could also use the output right here, or I mean the other side, because there's two opamps in here. You can use that for another amplifier, or even make a buffer out of it. And if you know a little bit about how operational amplifiers work, please write in the comments fields below. Would this circuit benefit when it is actually an operational amplifier? Would it also, or I mean a non-inverting amplifier, would it also gain something if I would make it go through a buffer after the amplification stage? What do you say? And please, if you are saying something, it would be very, I mean, if you suggest something, it would be very helpful if you could link to some sort of evidence, so that everyone could understand where to find evidence for a particular design or something like that. Because just saying like this is how it is, it's not helpful for the community, because that might be helpful for you to make you feel like, okay, you are the man, you know how stuff works. But guess what? It doesn't help the community. And the community is everything, Humans are actually communious creatures. Without community, we have no reason to live and we want to die. Or something like that. At least having a community is helpful for your mental health. So now I connected the positive and negative leads right there. I connected everything except for what? Except for let's see. So this one right here, it should go. So this is here. Is this? You see that? No, I'm sorry. So this one is this one, and it should go to the inverting input, which is number 2 right there. So just one little cable more, and then we are ready to rumble, as they say. And of course this will be as interesting as turning the volume knob. I mean, the test of this module will be just as interesting as turning the volume knob on your stereo. But it's just one module in a chain of modules that together can make some crazy noises. Okay. Okay, this is making problems for me, because it's called my name is Problem Maker. Alright, so this is probably going to fail right here, and therefore I will zoom in for you so you can sort of make a short video of this video and post it on your social media and says, look at this guy, he's so bad at soldering. His channel is called Nerding and Hoarding, and I cannot solder, I can only make solder bridges. I mean, seriously. Sometimes it feels like most of my skills are not increasing but decreasing the longer I do something. So I've been soldering for 4 years, maybe. I mean, daily. Oh, I seriously fucked something up here. Yeah. Let's just hope that this upfucking is not so severe as it looks. It looks really bad. Yeah. I have to double fix that, because I mean, this is really not so good. Okay. And I have been an artist, like painting, drawing, sculpture, making, video art, making artist for 20 years, and I have just, it's like I unlearn every day more and more. So now I have no idea what actually art is at all, which is kind of sad, because it's supposed to be my livelihood. But instead I learn what what analog electronics is. So now I'm just I'm just putting this red wire here to indicate which side that we should connect positive voltage to. And just for the hell of it, why don't I put the blue on the other side to indicate where to put the negative voltage so that it becomes extra clear. And also, why don't I put it from the other side? I mean, why do I insist in making things harder than they need to be? Well, because you're so quick and dirty. And maybe you're an ADHDer. Well, maybe, but no doctor wants to check me out because it costs too much. Alright, so there you go. Yeah, it's better to take the input from the back side up through the copper side and then solder it down. So if you ever seen anything quite as messy as this, please post an image of your worst soldering, and you can win a Vactrol that I made myself. And also, if you know how to open an online shop, I want to open an online shop so I can sell, I mean, these cool modules and, you know, other stuff. So now we're ready right here. We are ready. So what do we do in this channel when we are ready? Well, we do a little something called testing it. So, right, so when I attached the power, something burnt up. And you know, on this channel you get to see burning components and all that. It was the resistor connected between the output and the negative input. So why is that, you might ask? Why would a resistor burn up? Well, most likely it's because it gets too much energy going through it. Yes, and as I said, I should put a 1K on the output. I forgot to do that. So maybe it was that made it so. And you know, if you build something that burns up, please don't expect it to work. But you know, I'm stupid, so I can still expect this to work, even though one component burnt up. Because hope is the last thing that leaves a person who is a sinking ship. And I am definitely a sinking ship if you consider my track record. You know, burning components, it has a very special smell, and it's actually quite romantic, you know. It smells like sort of electricity, but still also, I wouldn't say it's the smell of success, it's more the smell of sort of excitement. Anyway, I will still try, because you know me, I want to succeed. So yes, the output has a something right there. Okay, I put the output and the output right there. Bam! Now we just need an input. So I take some kind of noise thing right here, and I need a really long wire, like all this, right here. Bam! So, by the way, if you hear this sound right here, it means that something is probably burning in your circuit. So if you just take a quick glance and feel your components, You know, now this time it's the operational amplifier right here. It's real fucking hot. So that means that you did something wrong. I'm just kidding. I did something wrong. So what did I do wrong? Well, that is the $100 question. And unfortunately, I have no idea. So I'm real sorry for this, guys. It's totally on me, this one. So, and if you're good at sort of looking for what is the problem with something you built, then please let me learn from you, because I have no idea. You know, when something's not working for me, it's like, okay, it stopped working. So, well, it's supposed to sound a bit like this, I think. Okay, that makes sense. Okay, so it's supposed to sound like that. Nasty noise right there. But it's not even making one little noise. What is this? You know, what is this? Seriously, it should work. Shouldn't it work? Yeah, but one component burned up. Yes, you are so correct. Thank you for making me remember that. And then look for the solder bridges. Well, there's no more solder bridges right here. Oh, that's good. That is good. That is really good. Do you hear that? Do you know what that means? If there's more signal when you don't have your ground connected, what does that mean? This is extremely hot. What does that mean? What does extremely hot component mean to you? Well, I have no idea. Would you look at that? There's some kind of dirt underneath here. Sort of like if this was your car, sort of like a dead dog underneath. So if we remove the dead dog, what about it? Well, it's still very hot, sort of like 100 centigrades. Which means, ow. Okay. Alright, then I will do some brain work right here, which I call, you know, thinking. Because I'm so cool, I use my own invented language. So how about just adding a new resistor right there? And now, just by random, I picked a 39 cares. So listen to this. But we don't have any input, so there's nothing to listen at. So, alright people, listen to this. Listen and learn. Nerding and Hoarding is here to teach you how to do quick and dirty DIY electronics. So there's nothing. Oh fuck, this is really hot right now. So let's just double check if we have any short circuits on the back side. No, we do not. That's good to know. So what could be the problem right now? Yes, feel like a guy just looking underneath the hood of his car and saying, that's interesting, but having no idea actually about what he is doing. So, well, if we do something like this, we take the burnt resistor right there, cut it off, and solder on a new one, brand new, fresh one. This is definitely gonna fail. Do you know why? Because there is such a blob here of solder, such a huge blob, that there is no chance in hell that it's possible for me to solder to it. But you know why? I'm so impulsive that I can't stop. I have to do it anyway. I have to try, even though I know that I will fail. Because that's just how I am, you know, that's the kind of guy I am. I'm not even adding any new solder because I'm also that kind of guy who believes that it's impossible to solder something without adding new solder. But that is extremely hard. So I have to find some solder somewhere, because I just ran out of mine. You see? Alright, so. Well, if you believe that I am going to be able to build an automatic gain control when I can't even build a non-inverting amplifier, then maybe you are wrong. I just press it like this, okay? And we test if there's coming any sound. There's coming no sound. So, and this is really hot right here. Everything is hot. Everything is hot. So, did you hear that? It sounded like something. Alright, so I am ready to give up, but first let's just do some kind of standard. So I will teach you how to try to check a few things, you know. I mean, I'm not totally without knowledge on how to check things that are not working. So first thing to do is keep the power connected and measure if you have incoming voltage. And yes, we have incoming voltage on the negative side. Do we have it also on the pin? Yes, we have. Do we have incoming positive voltage? Well, what do you know? We actually don't have any incoming positive voltage. Or, I mean, we have the positive incoming voltage is -3 volts. So that's good to know, but what does that exactly mean? So I double check on the power supply. The power supply is giving me 0 volts on the positive and 0 volts on the negative. So that's kind of strange, but yeah, I just realized that I measured on something that's not connected. So I connected to here, to my power supply, and guess what? We are having voltage on both kinds that we want to have, positive and negative. So that makes me think that the positive is somehow short-circuiting something, and probably that is why we are not experiencing any outgoing voltage and a lot of heat right here. So if I connect this again to the power, oh, did you hear that? It almost sounded like a noise that we want to have. Okay, so now just double check again. Do we have any incoming positive voltage? Well, what do you know? Now we got it. Now we actually got it. So let's try to listen again to the circuit. Yes, but I forgot to solder on the resistor. So where's the resistor now? I put it somewhere. I know I put it somewhere. Oh, look, a little bit of solder. That's good to have. Can you hear that? Sounded like sort of noise. I mean, you know, like white noise. It's hard to talk about noise because noise means both a sort of music, but also a sort of electronic signal. I mean, seriously. Now I'm getting a bit sad. I'm really getting a bit sad now. Could this please work? Just please, for this one's right here. Alright. So let's make a nice little, let's try to make this into a learning experience. So please write in the comments field, what are the things that you believe that I did wrong during this build that led up to this failure? And please suggest better methods to use. Do you hear? There's some kind of noise here. Listen. You hear? That is a real nice sound right there. Wonder if we have that if we remove the input. Yes. Sure. Let's just double check a little bit here, a little bit there, and then I say, well, thanks for watching, and as always, we will finish off with a nice little jingle.
Nerding and hoarding. Quick and dirty DIY electronics. Nerding and hoarding. Quick and dirty DIY electronics.
So, help me become better.
Nerding and